Hey, welcome to the second part of our cinnamon example project. In the last video, we already presented our cupcake factory in detail. If you haven't watched the first part, we recommend doing so for a better understanding.
Previously, we talked about the difference between the AbstractModeNode and the AbstractModeNode. As we know, the AbstractModeNode includes different operating modes like homing, automatic, and manual. Every object that inherits from AbstractModeNode has these mandatory, abstract run methods. Run homing, run automatic, and run manual. By default, these methods are empty and need to be implemented. Additional default methods can be created manually.
When we create a new class called Showcase that inherits from AbstractModeNode, we see that the run methods are automatically added. The other methods come from AbstractNode and AbstractObject. AbstractObject is the mother of all classes.
Mother.
A very important property that we need to mention now is the className property. This must always be set. Here, in the getter, you assign the name of your class. In our case, Showcase. This property allows classes to be identified later, which is primarily important for debugging. As we said earlier, no matter which cinnamon library you're exploring, everything is derived from AbstractObject. AbstractNode inherits from AbstractObject, and AbstractModeNode and AbstractCyclicNode inherit from AbstractNode.
Mother.
Every node has a node state. The different states are defined in the SingleExecutionState. In general, nodes should be in the success state. The states are being checked. If, for example, a node is in an error state, this error is propagated up to the root node.
Let's have a look at the HMI. We start our factory in automation mode. If a child node is busy, this status propagates through the entire tree. Furthermore, every node has the following requests: initialize, enable, stopImmideate and disable. They have to be implemented for every node/device. For example, if a stop is requested, it is executed through the entire tree.
If you are programming a sensor, you can leave the stop method empty or just return success. A cylinder, on the other hand, can be stopped, so it makes sense to implement the logic here. Let's take a look at our supply unit. Go to Portal and then Axis. The axes are drives and also have stop methods. The stop method for a drive is already implemented because it comes from a component of our Cinnamon device project. Because our nodes are divided into very small units down to the hardware level, the portal does not need to manage stopping the axes itself. The axes handle this independently. In their own stop methods, we have clean, organized code that is responsible for stopping each respective axis. In the portal, we would otherwise have had to create a long step sequence to stop all axes.
When we start the PLC, the initialize method is executed first. The opmode handler checks if it receives success from all nodes. This method is primarily intended for setting parameters. In our distribution unit, for example, we use it to differentiate how the crocos and the catapult handle the cupcakes. The crocos recycle them, while the catapult shoots them to the dinosaur. The opmode handler checks if safety is OK, returns true. If it does, the enable method is executed. Enable is important for anything that moves. Let's look at our axes again. This method enables a node. It can take multiple cycles. It has to be implemented for every node. The intention is to enable devices, for example, axes, lasers, dispensers, and so on. The execute input needs a rising edge to execute the method. If there is nothing to enable, just return a success state. The method is called automatically by the operation mode handler. If the stop button is pressed or an emergency stop is triggered, the stopImmideate method is executed. This method stops all movements of a node. It must be overwritten for every node. For example, axes should perform a quick stop and cylinders should be turned off. If the node should do nothing, return success. The stop method should stop axes, cylinders, processes continuously until manual mode is stopped via stop request or immediate stop. This method is called automatically by the operation mode handler before disabling the machine or if the operator selects an immediate stop. Attention! If this method returns the state error, the operation mode handler automatically disables the entire machine.
If safety is no longer OK, the disable method is executed. As the name suggests, this method disables a node. It can take multiple cycles. The intention is to stop all movements. The execute input needs a rising edge to execute the method. If there is nothing to disable, just return a success state.
Next, we talk about another important property, the isInHome property. Every node has it because every node inherits from AbstractModeNode, which defines it. This property is very important for our HMI because it indicates that a node or subunit is home in position. It has a getter and a setter. The getter only returns true if all child nodes of this node are also in home. If any child node is not in home, the parent node is not either. This propagates all the way up to the root node. The setter sets an internal flag, a boolean, indicating whether the node is in home position. Let's look again at our portal and its axis. Here we see that the home state of the portal and the station changes when we manually move our axes. Could our isInHome property have something to do with this beautiful display? I think so.
With this beautiful image of the Cinnamon HMI, we conclude part 2 of our video series, in which we work with our Cupcake Factory example project. Take care, and we'll see you again soon for part 3.